In this video, we're going to do an example of solving a recurrence by induction. So here's a sample problem to solve the difference equation given by, defined by a sub 1 equals 1 and a sub n equals n minus 1 over n times a sub n minus 1 plus 1 for n greater than 1. All right, so we need to find a formula for the ANs in terms of n. And looking at this, it's not very easy to see what a formula could be. So a good way to get started would be to calculate the first few terms. So, well, we're given that a1 is 1. Notice that we cannot use the recurrence to actually figure out what a1 is. But we can use this equation that relates an and an minus 1. We can use that to find a2. So a2 is when n is 2, so we get 2 minus 1 over 2 times a sub 1, which is 1, plus 1. So that's 1/2 plus 1, which is 3 over 2. Let's calculate another one. A sub 3 is 3 minus 1 over 3, so that's 2/3, times a sub 2, so that's 3 over 2, plus 1, you get 2. And let's calculate one more. A sub 4 is 4 minus 1 over 4, so that's 3/4 times a3, that's 2, plus 1. So you get 6/4 plus 1, that's 5 over 2. So the first few terms are 1, 3 over 2, 2, and 5 over 2. So this is when, so the first one's A1, the second one's A2, next one's A3, and next one's A4. So based on this, do you have any guesses for what the formula might be? Well, it seems like each time you're adding a half, and so you might try looking at, okay, well, what might it be? One guess would be that a sub n is n plus 1 over 2. Because at least it works for the previous ones, for the ones that you've tried. So that doesn't prove that this works for all n, but this is a reasonable guess. So now let's prove. So we'll prove that a sub n is n plus 1 over 2 for all n. So the first step is to use induction. We're going to prove this using induction. So the base case is when n equals 1. Well, in that case, a sub 1 is, we're given that a sub 1 is 1, and is that equal to 1 plus 1 over 2? Well, yes, it is. So the base case is proved, and now we need to do the inductive step. So first we assume that the equation holds for a sub k. So we assume that for some k, a sub k equals k plus 1 over 2. And we want to show that a sub k plus 1 equals k plus 1 plus 1 over 2. Well, how are we going to use a sub k to calculate a sub k plus 1? We use the recurrence relation. Right? So by the recurrence relation, we have a sub k plus 1 is k plus 1 minus 1 over k plus 1. Is that right? Yeah. Times a sub k plus 1. Well, that's equal to k over k plus 1 times k plus 1 over 2 plus 1. Now the k plus 1's cancel, and so you get k over 2 plus 1, and that's equal to k plus 2 over 2. And that is equal to k plus 1 over 2. And that completes the proof by induction. So let's go over the general strategy for this. First, we're given this difference equation. It's not easy to see what the ands are. So we calculate a few terms, and then we make a guess as to what the formula should be. Now, the formula might not work. In this case, it worked. But once you have tested a few values and you think you have a formula, then you have to prove it. And for recurrences, generally speaking, it's a good idea to use induction, because you're trying to prove something for all integers, or for all positive integers. Induction is natural for that. And another reason induction is a good idea is because induction takes you from one step to the next step. And in a recurrence, right, the AN is defined in terms of the previous guy. So it's natural to use induction for proving facts about recurrences.